welcome to 7.2 Perpendiculars and Bisectors. Before we get started, I want to just do a quick review on this slide. I want you to think about how many ways three lines in a plane can intersect. Okay, and I'll give you the answer in a couple slides. Okay, so before we jump in with new theorems, I want to talk about those. There are four cases in ways that three lines in a plane can intersect. The first case is that they're all parallel. Okay, they intersect 0 times. Another is that they intersect 1 time. All three lines intersect at the same point, which is called concurrent. And then they can intersect in 2 lines, where you have 2 parallel lines and a transversal, right? And then you have 3 points of intersection. And I just want to remind you of the idea of concurrence before we jump into this. Okay, so first theorem. Okay, so besides right triangles, perpendicular lines are also used in several other ways. Okay, so we are going to beat into our heads all the different ways that we can do bisectors and perpendiculars. Okay, so any point lies on a perpendicular bisector of a segment if and only if it is equidistant from the 2 endpoints. So here's a segment and here's a perpendicular. Okay, I could have drawn that line anywhere on that segment, right? Okay, so here's point C. Now it lies on the perpendicular, right? I could move point C, could be anywhere as long as I could draw a perpendicular along that line. So also I can make a little triangle, right? Isn't this a right triangle? And this is a perpendicular bisector, not just a perpendicular. So we have to be more specific than just a perpendicular. Now I have a bisector, which means that the segment AB is now has 2 congruent parts, AD and DB. And that also means segment DC is congruent to itself. So I have side angle side, or I have leg leg, whichever theorem you want to use, which means those hypotenuse dashed lines are also congruent. Okay, so we've already reviewed this, but I just wanted you to hear me say it verbally before I showed it to you visually. Also, before we move on to this again, I want you to look at the proof of the last theorem on page 267. Alright, it's important that you look at these proofs. I can't stress that enough. They're on quizzes and tests, as you probably have realized by now. Okay, so here are the 4 points that I was talking about just verbally. I just said them out loud. But they don't intersect because they're parallel. They intersect 1 time because they're concurrent. They intersect 2 times because 2 are parallel and 1 is a transversal. And then there's 3 separate points of intersection. It looks more like a triangle. Alright, so the first way we're going to intersect 3 lines is called a circumcenter theorem. Okay, the perpendicular bisectors of all the sides of any triangle are concurrent at the circumcenter, which is equidistant from each vertex of the triangle. So let's see a picture of that. Okay, so the definition of circumcenter says we need perpendicular bisectors of the sides. So I need to take a perpendicular bisector of each side, and we know how to construct this. We know how to do perpendicular bisectors. And this is another perpendicular bisector. This is another one. Now you see they are concurrent lines. They intersect at 1 point inside the triangle. Now that point you could measure with a ruler, you could measure with your compass, but if you go from the center of those yellow lines to the vertex of any of the 3 vertices of that triangle, they are going to be equidistant. And then if that's the case, that means you have radii, right? You have 3 different places you can measure the exact same measurement of a radius, and you can draw a circle where the vertices of the triangle lie on the circumference. That is why it's called the circumcenter, because those vertices lie on the circumference of a circle. Okay, you're going to learn several, and these are going to be really easy to mix up. Okay, so I'm going to show you kind of a summary slide at the end, and that is going to be, you know, your little gold card. Alright, so the next one we're going to talk about is the incenter, okay, an angle bisector. So before we did segment bisectors, now we're doing angle bisectors of the triangle. They are concurrent at the incenter, which is equidistant from the sides of the triangle. Let's look at a picture. So I have to bisect each one of the angles. Now this center now is not equidistant from the vertices, but equidistant from each of the segments. So I'm going to inscribe a circle, because now I have a new kind of radius where I can draw a little circle inside, or inscribed, the triangle. Okay, so just a review of what an altitude is. It's a segment that extends from the vertex and is perpendicular to the opposite side. But be careful with the word altitude. You're used to calling it the height of a triangle. When you went to find area, you did half base times height, correct? Altitude is height. It is not a perpendicular bisector. It is just a perpendicular that is dropped down. I will show you a picture in a moment. And then the median is a segment extending from the vertex to the midpoint of the opposite side. So midpoint would be the bisector, but you're moving from the vertex to that midpoint, so it's not going to be perpendicular. Alright, so we're kind of mixing up some terms here. Let's look at a picture. Okay, so in altitude, this is what it looks like. You're used to calling it height, but now we're going to call it altitude. The median is the midpoint of the segment from the vertex. So you see how it is not perpendicular, but it's meeting at the midpoint. Or if you were to bisect that segment, that point is where the vertices is drawn, that yellow line. Okay, so now we get to move on to the orthocenter. The lines that contain 3 altitudes are concurrent at the orthocenter. Okay, so concurrent means, right, they meet there, they intersect at one point. So now we have to draw altitudes, and we need to draw that perpendicular that is not a bisector. The perpendicular goes through the point A. Now I've got to draw a perpendicular that goes through the point B that is a perpendicular to AC. Okay, and now I have to draw a perpendicular that goes through AB but includes point C. And now I have this new point. It's called the orthocenter. Okay, so now I have the centroid. This is the last one. Remember I told you there were 4. Now I'm going to be talking about medians. So there's a lot of vocabulary in this section, I understand, and it's so easy to mix up which one is which. So I'm going to, like I said, I'm going to show you a chart that will summarize it all for you. But I want you to take down these theorems as we go, just like normal. Alright, so let's look at medians. If you remember what a median is, okay, it extends from the vertex to the midpoint of the opposite side. This would also, in physics, this would be called the center of mass. Every object that has mass has a center of mass. So in most people, the center of mass is your belly button. Not always, right? It's somewhere in your lower torso, so that if you literally were to be able to balance a pencil on your finger, that is your center of mass. Anywhere where there's balance, it's equal weight, if you will, on both sides. So this would be a center of mass of the triangle. Alright, so here we go. We're going to need midpoints of all the segments, and then from that midpoint to the opposite vertices. Okay, so this would be the center of mass, or the centroid, of this triangle. Now let's practice some vocabulary. The angle bisectors are congruent at the incenter. So I remember angles being inside the triangle, incenter. Altitudes are concurrent at the orthocenter. These are some, you're going to have to come up with little ways for your brain to remember it. Which point of concurrency is illustrated here? Right, this is the one we just did, centroid, so we've got midpoints to vertices. Okay, so this is the overview. If I was in Mrs. Kirk's geometry class and I was about to take a quiz or a test over these concurrency points, I would make an index card and memorize this. For your whisk summary, in your own words, I want you to tell me the difference between medians and angle bisectors, and you need to include a sketch when you email it to me with appropriate labeling, and I will see you in class.